Hi everyone, today we're going to be looking at quadratics in terms of their different forms, solving, and a focus on vertex form and how to move between them. And it will sort of culminate in a round of practice questions with worked solutions. Okay, so the first thing that you need to be aware of is the three different forms of a quadratic function. So we have the standard form, we have factorized form, and we also have the vertex form. Okay, so standard form is your y equals ax squared plus bx plus c. You will also see this written as f of x is equal to ax squared plus bx plus c. Okay, you could also have g of x, h of x, whatever it is, it's still a function, okay, and it's a quadratic function. You will also see factorized form written as f of x is equal to x minus p, x minus q. Okay, again, that could be plus or minus. It could be a combination of the two. It could both be positive as well. Okay, but it's still the same thing. And then, of course, we have the vertex form, which is written as y is equal to a brackets x minus h all squared plus k, where hk is the vertex. Okay, so just as a very quick example, if we had something like x minus 2 all squared plus 3, then here 2, 3 would be our vertex. We will come back to that in a little bit more detail later on in the video. Okay, so here are our main properties of quadratic functions. So these are all different formulas to be aware of, okay, specifically in relation to vertex form, okay. So for a quadratic function f of x, which is equal to ax squared plus bx plus c, we can find the x coordinate of the vertex by completing minus b over 2a. We can find the equation of its axis of symmetry, which is ultimately its mirror line, and that's by doing x is equal to minus b over 2a. We can find the coordinates of the vertex by, first of all, finding the axis of symmetry and the x value, and then putting that specific x value into the function. Okay, we can also find the y-intercept from the form from the standard form of the quadratic function. So that's just going to be your c value. And then we can also find the x-intercepts, x1 and x2, by equating the equation to 0. And we can also find the x-coordinate of the vertex by doing x1 plus x2 over 2, and then substituting this answer into the function to find the y-coordinate. So various different ways and different information to find various aspects of the vertex. Really, you need to know these off by heart. So yeah, pause here, note them down, and try to remember them. For this part of the video, we're just looking at converting quadratic forms. So have a read through of this information by yourself if you want. So just pause here, or I will go through this for you. So to convert from factorized form to standard form, we simply expand the brackets. So I'm looking at this part here, and to move from this form into this form here, we would use FOIL, okay? Which is just our expanding technique. Okay, you may have your own, which is fine, but FOIL is sort of the most popular name for it. Okay, then if you can factorize a quadratic function, you can convert it from standard form to factorized form. So that's going from the ax squared plus bx plus c into our bracketed form, so x minus p, x minus q. And then we can convert from vertex form to standard form by expanding and simplifying. So you've got a good example of that there. Okay, now the big one is to be able to convert from standard form to vertex form. Now, to be able to do this, you need to know how to complete the square. Okay, so that's what we're going to look at next. Okay, before we get started on converting from standard form to vertex form, let's just quickly delve into what is vertex form a little bit more. Okay, so the vertex form of quadratic function is given in this pink box where hk is the vertex. Okay, so what does this really mean? Okay, so if I look at my two examples here, and I want to pull out hk, so hk, so the vertex of this first equation would be -4 minus 2. So what does that really mean? Okay, so if I was to graph this function, it means that my turning point of this graph, i.e. the minimum or maximum, is going to be at -4, -2. So somewhere around here, -4, -2. Okay, now I know that it's a positive x squared, so it's going to be concave up or opening upwards. Okay, so that's roughly the shape of this particular quadratic. Okay, if I look at my next example, so we have f of x is equal to x minus 2 all squared plus 5. My vertex for this example, okay, so remember I'm pulling out hk, so this time it would be 2 comma 5. Okay, now again, this is still a positive quadratic function, but my vertex now is going to be somewhere here. Okay, so I know that it still is a quadratic that opens in an upwards direction, but my vertex is going to be in the first quadrant rather than the third. Okay, so make sure you are confident with pulling out the vertex. Remember that the formula, okay, has a negative here. Okay, so in that first example, we had a positive 4. Okay, that means that our vertex is actually negative. That double negative is what creates the positive. So on the flip side, if you just have a -2, like this second example, okay, it actually means that the vertex is at +2. So we should also discuss what the a value does. Okay, you can see in the formula that we have an a value in front of the x minus h all squared. So to note, the a value controls how wide or narrow the parabola is. Okay, so I've got two examples here, both exactly the same, except for my first equation has an a value of 1. Okay, and for the second example, we have an a value of 2. So a is equal to 2. Okay, so a few things to note. You can see that the vertex has stayed the same, and that's because our h and k values are both the same, but our intercept, our y-intercept values at 3 and 4, they are now different. Okay, so that a value has made this second quadratic narrower or steeper looking. Okay, it's pulled it in an upwards direction. So now the y-intercept is higher than previously. Okay, I've put them both onto the graph here so that you can basically see them side by side and how they look. But like I said, you've got the same vertex in both, but the y-intercept values are now different, and the shape of the parabola for the second one with an a value of 2 is now pulled in an upwards direction, making it narrower and sort of steeper looking. Now we're going to look at converting to vertex form. So here you need to be confident in your completing the square skills. So for this first question here, we've got write x squared plus 2x minus 2 in vertex form. Okay, so I'm going to complete the square. So the first thing that I need to do is open my bracket, and I'm going to half my b value. Okay, so here I've got plus 2 as my b value. So half of that would be plus 1. And I'm going to close the brackets and square. Okay, I now need to subtract that b over 2 value all squared. Okay, so I'm going to subtract 1 squared, and my minus 2 that I had in the original equation is going to come down also. Okay, so now what we need to do is basically simplify this part so that I've got a fully simplified vertex form function. Okay, so y is equal to x plus 1 all squared, 1 squared, so minus 1, subtract 2. So overall, I would have x plus 1 all squared, subtract 3. Okay, this is now in vertex form, so I can pick out the vertex. So my vertex would be minus 1, minus 3. Okay, so onto the second part of the question. It asks us to now sketch the graph of y equals x plus 1 all squared minus 3. Okay, so let me just start with my axes, zeros in the middle. Now, using the first form, so the standard form, I know my c value is -2. Okay, now your c value is your y-intercept. Okay, and I know that my vertex is at -1, -3. Okay, so -1, -3 is going to be about there. And I need to stop and think to myself, is this a parabola that opens upwards or a parabola that opens downwards? Now I know that it's a positive x squared, so it's going to open upwards. So my turning point, or my minimum, so to speak, is at -1, 3. That's terrible. Let me just try. Oh, okay, let's just try that again. Okay, something like this. Make sure it goes through that -2. Oh my goodness, what is going on? Okay, and it opens in an upwards direction. Okay, this is just a sketch, thank goodness. You can delve into this a little bit more. Okay, so if you wanted to actually find the x-intercepts, you would take your vertex form. So let's do this now. We've got x plus 1 all squared minus 3, and I'm going to set that equal to 0. Okay, so x plus 1 all squared is equal to 3. I'm going to square root, so x plus 1 is equal to the positive or negative of root 3. So then x is going to be equal to -1 plus root 3, or x is equal to -1 subtract root 3. So you could put that onto your graph as well in terms of the x-intercepts. So this one here would be your -1 plus root 3, and then this here would be -1 minus root 3. So looking at this graph currently, I kind of know that this is not very accurately drawn, and I would want to probably shift this a little bit just to make it a little more accurate looking. But in terms of your labeling, as long as your labels are correct, you will get the marks. Okay, you would also, in terms of the e-assessment, have some sort of drawing tool to help you do this. Okay, so it would be easier to draw this more accurately. Okay, here are some more examples for converting to vertex form. So the first one we have here is x squared minus 4x plus 11. Okay, so I'm just completing the square. We have a single x squared. So this is sort of the easiest type of example that we could get. So just go ahead and we're going to start our bracket. With x, we're going to half our b. So half of 4 is -2 all squared. We then need to subtract this -2 squared, and then our 11 comes down. Okay, so let's just simplify this further. X minus 2 all squared stays the same. We have subtract. Now -2 squared would be 4, so subtract 4 plus 11. Okay, to simplify further, we would have x minus 2 all squared Negative 4 plus 11 gives us plus 7. So for here, if we were asked to find the vertex, we would write that it is 2, 7. So it's at the point 2, 7. Okay, on to question 2. So 2x squared plus 12x plus 1, and we are again completing the square, although this time we have a number higher than 1 in front of the x squared, so we do need to factor that out first of all. So I'm going to take a 2 outside. That would leave me with x squared plus 6x inside of the brackets, and then we have plus 1. Okay, so now when I'm going to complete the square, I have to remember that this 2 is outside of the bracket, okay, because we will need to distribute for this as well. So inside we're going to have x plus 3, because 3 is half of 6, all squared, and we need to subtract that 3 all squared as well. Then we can close our square brackets and our 1 comes down. Okay, so to simplify this further, we've got 2 open bracket x plus 3 all squared. Now 3 squared is 9, so that's going to be minus 9. Okay, and then we've got this plus 1 outside. So now I'm going to distribute the 2 inside of this square bracket. So I'll have 2 bracket x plus 3 all squared, subtract 18 plus 1. To simplify further, 2 bracket x plus 3 all squared, and that's going to be minus 17. Okay, so our vertex for this question is going to be at minus 3, minus 17. Okay, on to the final question. So here we have a quadratic in factored form. So the first thing that we need to do is expand. You can do this through FOIL. So first is x squared, outer is going to be plus 2x, and we have inner plus 4x, and then our last, which would be plus 8. Let's simplify this. So we have x squared plus 6x plus 8. And now we're going to complete the square as usual. So open bracket, x plus half of our 6 would be 3 whole squared. We need to subtract the products that we get from the 3 times 3, so minus 3 all squared, and then our 8 comes down. So let's continue to simplify this. We would have x plus 3 all squared, subtract 9 plus 8. My final line would be x plus 3 all squared, and then negative 9 plus 8 leaves me with minus 1. So our vertex for this final question would be at minus 3, minus 1. And there we have it. Okay, so moving on to more of the properties of quadratic functions, specifically in relation to vertex form. If you would like to pause this and have a go at this yourself, please feel free to do so. I am just going to work through only 2 examples, just going through the different parts and making sure that it's clear what we need to do. So for the first equation, we have y equals x squared minus x minus 6. So the first thing that it asks me to do is find the coordinates of the vertex. Okay, so because it's in standard form, I can use these formulas on the right hand side. So the first thing I'm going to do is find the x coordinate of the vertex by using the minus b over 2a. So x is equal to minus b over 2a. So for this, I should write here. So a is 1, b is minus 1. So our x is equal to negative minus 1 over 2 lots of 1. Okay, so you want to either put that into your calculator, or if you're confident, that's absolutely fine. So here, our x is equal to a half. Okay, we now need to find the y coordinate. So we're going to substitute that in to the equation. So I've got a half all squared minus a half minus 6. Okay, so pop that in to your calculator. A half all squared is equal to 1/4. quarter minus a half minus 6. So your y value would be equal to minus 6.25. Okay, so in terms of your vertex coordinates, you would want to write a half, comma, and then minus 6.25, okay, or equivalent, whichever way you want to write it, that's fine. So in terms of part 2, it's axis of symmetry. Let me just label this a little bit better. So that's part I. We have part 2. Definitely not giving myself enough room here. So find the equation of its axis of symmetry. That would be x is equal to a half. Okay, part 3. Determine whether the function is concave up or concave down. This would be concave up. I know this because the x squared is positive. Okay, find the y-intercept. So I go back to my standard form equation and I can see that it's x squared minus x minus 6. So the y-intercept is going to be equal to negative 6. Intercept is equal to negative 6. Okay, so in terms of how to write this as a coordinate, you would write 0, comma, negative 6. Okay, part 5 says if the function is factorizable, find the x-intercepts. Okay, so we're looking to write this in the form of y equals x minus p, x minus q. Okay, so there's various methods of how to do this, but you ultimately need to decide if it is factorizable. Okay, this particular example is we would have x plus 3, x minus 3, x plus 2. So x minus 3, x plus 2. Therefore, my x-intercepts, so I would set all this equal to 0. So I'd have x equals 3 or x equals negative 2. I have skipped a couple of steps there. So if you do need to go back to the factorized form and just look at how you solve using factorizing. Okay. And then for part 6, in terms of drawing a sketch of the quadratic function, okay, we need to use all of the points that we have found. Okay, so I know, first of all, that my x-intercepts are negative 2 and 3. Okay, I know that my vertex is a half minus 6.25, so somewhere down here. And I know that it's concave up, okay? So if I just label these points, okay, we've got x equals minus 2 and x equals 3. And then I just need to, oops, I don't know why I put that in brackets, but never mind. Just need to draw my parabola going through these points, okay, as best as I can. The other label, that I missed out there was that our y-intercept is at negative 6 as well. So just make sure that one's labeled as well. I was going to go through both, but I have run out of room. If you need any more help on this, please let me know and I will go through another example. Okay, we are on to our MYP e-assessment practice questions. So here we have a question that says a ball is thrown and its height in meters is given by the function h of x is equal to negative x squared plus 6x plus 5, where x is the time in seconds. Find the maximum height of the ball. So we are looking for a maximum. Now this should signal to you that we are looking for the vertex, okay? So going back to our formulas, I can find the x coordinate of my vertex by calculating minus b over 2a. Okay, I could complete the square here, but because it is a negative x squared, it does make it slightly harder because I have the function in standard form already, it is easier to use the formulas available to me. So I know my a value is -1, my b value is 6. Okay, so I'm substituting those in. I have x is equal to -6 all divided by 2 lots of a, so -2. Okay, so that gives me an x value of 3. Okay, once I have my x value, I can sub this in to my function to find the y value. Okay, so h of 3 is going to be equal to -3 all squared plus 6 lots of 3 plus 5. So h of 3 is equal to -9 plus 18 plus 5. So h of 3 is equal to 14. So my maximum height, or my maximum point, let's say, first of all, would be at 314. But I have to remind myself that I'm finding the maximum height, okay, which is my y value. So the maximum height here for this question is going to be 14. My units are meters, so maximum height is 14 meters. On to our next MYP e-assessment practice question. So here we have a fountain shoots water from the ground, and the path of the water is modelled by h of x is equal to -2x squared plus 8x plus 1, where h is the height of the water in meters and x is the horizontal distance in meters from the nozzle. Determine the maximum height of the water in the horizontal distance it occurs. So again, we are looking for the vertex, okay? For this question, I will solve it by completing the square, just so that you've seen both examples. So let me just rewrite my function and let me talk you through completing the square. So the first thing we need to do is basically factor out the -2. Okay, so I have h of x is equal to -2 brackets x squared, minus 4x, and then I have my plus 1 also. Okay, so our next line of working. So this is where it gets a little bit more complicated, okay? So we've got our -2 impacting that bracket, okay? So when I complete the square, I have x minus 2 all squared, but then I'm going to have to subtract that -2 all squared, but that is still going to be impacted by this -2, if that makes sense, okay? And then I have my plus 1 outside of that, okay? So then we have, to simplify further, our -2 bracket x minus 2 all squared. Let me keep in that square bracket for now. We are going to be subtracting 4, okay, and then we have our plus 1. Okay, so now I'm going to effectively distribute the -2 or multiply out everything inside of those square brackets by this -2. So my -2 can stay as it is before the bracket of x minus 2 all squared. I now have -2 multiplied by -4, which is going to give me a positive 8. And then my 1 comes down. So to simplify fully, we have -2 bracket x minus 2 all squared plus 9. Okay, so when I think about the final vertex here, okay, my vertex would be at 2, 9. Okay, so let's interpret this. It's asking me for the maximum height of the water and the horizontal distance it occurs at. So the maximum height is going to be 9 meters. And the horizontal distance that it occurs at, so the horizontal distance would be the x coordinate, which is 2 meters. Okay, just leave that written as meters so I don't spell it wrong. Okay, and there we have our answer for this question. Now we are on to our final e-assessment practice question for this video. So our question says we have a seal that dives into the water and its depth below the surface in meters is modeled by d of x is equal to 2x squared minus 8x, where d is the depth and x is the time in seconds since the seal started diving. So part A wants us to determine the maximum depth the seal reaches and at what time. State when the seal returns to the surface. Okay, so again, you've got a number of different ways that you can do this. Entirely up to you, which method suits you best. I'm going to complete the square just for that further practice, but otherwise you could use your minus b over 2a and then substitute that back in. It may be that you find that method easier, but anyway. Okay, so we have d of x is equal to 2x squared minus 8x. So the first thing that I'm going to do is factor out that 2 again. So d of x is equal to 2 bracket x squared minus 4. Oops, sorry. Yeah, I was right. Ignore me. Minus 4. And then we don't have... yeah, we don't have any c value currently, so we just leave that blank. Okay, now I'm going to complete the square. So we're going to have 2 bracket, let's put those square brackets in as well. So x minus 2 all squared, and we're going to subtract that negative 2 all squared as well. Okay, let's keep going, keep simplifying. Have 2 square brackets, x minus 2 all squared. My negative 2 squared is 4, so it's going to be minus 4. Now we're going to distribute the 2 or expand. So we have 2 bracket x minus 2 all squared and then minus 8. Okay, so our vertex is going to be 2, negative 8. So what does that mean? So determine the maximum depth the seal reaches and at what time. The maximum depth is going to be 8 meters and the time that it is reached at is 2 seconds. Okay, 2 seconds after it dived down. So quite a quick seal. Okay. Part B is asking us to state when the seal returns to the surface. Okay, let me just make a little bit more room. Oh dear, let me not do that. Okay, let me just talk you through how to do this. Okay, so if your seal has started at 0, okay, it has dived down to minus 8 meters, okay, and that's at 2 seconds. Okay, this represents your axis of symmetry. Okay, so it's asking you when it would resurface. Okay, now remember the distance from the start time to the axis of symmetry must be equivalent on the other side. Okay, so because it's been 2 seconds to get to the maximum depth, you know it must then be another 2 seconds before he resurfaces. So your total time until he returns to the surface would be 4 seconds for this situation. Okay, I hope that helps. Let me know if you have any questions. Just comment below, or yeah, you can send me a message on Instagram or anything like that. Okay, but thanks for watching and well done if you've made it this far.